Yeah, here we go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to wrap up section 8.2 by looking at part 2 of that. So let's go ahead and get started. The first thing we're going to talk about is finding the domain. So finding the domain. Now, we looked on Friday, I believe, at an example where if we put a number into the function, let's say we put an X value in, and the resulting Y value was undefined, that was not an acceptable result. Therefore, that input was not an acceptable input, like putting a rock in a meat grinder. So we need to figure out what values of input are going to cause undefined as an output. And those values we need to boot out. They are not part of the domain. Let's take a look at this first example. It says h of x equals 3x plus 6. It says to find the domain. Well, the only variable is in the numerator, so there's no value of x that we could put in here that would make this thing undefined. So the domain would be all real numbers. We're going to use interval notation, which if you took Math 85, it was introduced back in section 2.7. And if you didn't take Math 85, it still was introduced back in section 2.7. Let's see here. I'm trying to look and see what page. Well, and this is, it should be in your loose leaf textbook. It's section 2.7, which starts on page 162, at least in the hard copy of the textbook. But anyway, I'll do some reviewing of it. The way you write all real numbers in interval notation is you have parentheses, negative infinity, comma, infinity, parentheses. You don't ever put brackets around negative or positive infinity. That implies that there's an endpoint there. There is no endpoint with all real numbers because it goes in both directions forever. So we would say the domain is negative infinity to positive infinity. Any questions about that? All right, let's take a look at another example. And this is h of x equals 1 over x minus 4. Well, let's see here. We don't want the denominator to be 0. So we don't want that to happen. We don't want that to happen. When would that happen? Well, if x was equal to 4, h of 4 would be 1 over 4 minus 4, which is 1 over 0, which is undefined. So our domain is x not equal to 4. How would we write that in interval notation? Everything from negative infinity up to but not including 4 in union with everything after 4 on up to positive infinity. Okay, so I know this is a little bit harder to write than that, but this would be how you would say everything but 4 using interval notation. Any questions about that? Okay, how about this one? F of x equals x squared. Well, any real number that you square is going to produce another real number. It's never going to be undefined. So again, the domain would be all real numbers. What about this one? g of x equals the absolute value of x minus 7. Well, any real number minus 7 is still a real number, and the absolute value of a real number is either 0 or positive. So again, this would never be undefined. So the domain is all real numbers. What about this one? Let's see. T of x equals 15 over 1 minus 3x. Well, when would that be 0? Let's see, if we add 3x to both sides, we get 1 equals 3x, divide by 3, x equals 1/3. So the domain would be x not equal to 1/3, but using interval notation, negative infinity up to, but not including 1/3 in union with after 1/3 up to positive infinity. I'll be right back, just a second. Sorry, there was some noise that was disturbing me there, so I got rid of it. Hopefully. Okay, anyway, we okay with that? Any questions? Next thing we're going to do is to graph some functions. Recall the form y equals mx plus b. And this goes back to chapter 3, where m is the slope and b is the y-intercept. So let's say you had looks like z, y equals 3x minus 2. Okay, so your y-intercept would be at -2, and your slope would go up 3/(1), up 3/(1), and you draw your line, etc., etc. Okay, now, function notation. F of x equals 2x minus 1. That's basically just like y equals mx plus b. So your slope is 2, your y-intercept is -1. Okay, let's take this and go back up here. And let's look at that again. So f of x equals 2x minus 1. That's like y equals 2x minus 1. The slope is 2. The y-intercept is -1. So this would have a y-intercept of -1 and a slope that goes up 2/(1), up 2/(1), up 2/(1). Okay. And then we would draw our line. And there we have the graph of f of x equals 2x minus 1. Any questions about that example? Okay, let's take a look at another one. How about this? F of x equals -x plus 2. So here the slope is -1 and the y-intercept is 2. So you'd plot the y-intercept using the slope. You'd go down 1/1, down 1/1, down 1/1, etc. Lining up the points with a straight edge, we would get, oops, that didn't work. Let's try that again. There we go. So there's the graph of f of x equals -x plus 2. Any questions there? All right, how about this one? F of x equals -x. Well, here the slope is -1. The y-intercept is 0. So it goes through the origin, down 1/1, down 1/1, down 1/1, etc. Okay. And there is the graph of f of x equals -x. Any questions there? All right. How about the graph of f of x equals 2? That's basically what? Y equals a constant, which is a horizontal line passing through that y value. So what we're doing is we're using information that came out of chapter 3 from Math 85. Any questions about that one? Okay. And finally, let's take a look at this one. G of x equals negative 0.25x. Well, the slope would be negative 0.25 and the y-intercept would be 0, but negative 0.25 would be negative 1/4. So goes through the origin, down 1 and over 4. So there's the graph of g of x equals negative 0.25x. All righty, again, any questions about that? Okay, now, there are some rules that you would have learned if you did take Math 85. And again, it would be in this textbook we're using back in chapter 3. I believe it's like section 3.6. 3.5, 3.6. Okay. And let's see here. Let's just go through these rules. Number 1, to find an x-intercept, set y equal to 0. So basically, if you complete the ordered pair, something comma 0, the x value would be the x-intercept. And what do I mean by the x-intercept? Where the graph cuts through the x-axis. Okay. Number 2, to find a y-intercept, set x equal to 0. So complete that ordered pair. And that would give you the value that we call b, that is where it intersects the graph. Let's see here. On the y-axis. So this is the x-intercept, this is the y-intercept, okay? Any question about those two ideas? All right, let's see. Another one, we've just talked about it, y equals mx plus b. That's called the slope intercept form, where m is the slope and b is the y-intercept. Okay. Let's see. We have the slope formula, which is m, which stands for slope, equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is y's are on top, x's are on the bottom. Let's write that a little better. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1, slope formula. Okay. Let's see, what else do we have? 5, 6, the slope of a horizontal line is 0. The slope of a vertical line is undefined. Okay. Let's see. The equation x equals a number is a vertical line. The equation y equals a number is a horizontal line. Parallel lines have the same slope. And finally, perpendicular lines have slopes that are negative reciprocals. Okay, and I am going to go through all of that as we go along here, but those are all in chapter 3 if you want to go back and look at them in great detail. But let's just go forward here using these. Okay, this says, write an equation for a linear function whose graph has the given characteristics. It has a slope of 5 and a y-intercept of 0, -3. Okay, so basically I could say m is 5 and b is -3. Do you see how I got from the slope is 5, the y-intercept is -3 to m is 5, b is -3? Any questions about that? Okay, so using y equals mx plus b, we get y equals 5x minus 3, but it says write it as a linear function, so we'll use f of x instead of y. So f of x equals 5x minus 3. Any question about that example? All right, let's take a look at another one. This says slope is 2 and the y-intercept is 0, 11. So m is 2, b is 11, y equals mx plus b, y equals 2x plus 11, f of x equals 2x plus 11. Any questions there? Okay. Write an equation for a linear function that has a slope of 1/5 and passes through the point 10, 1. Okay, so I know that the slope is 1/5, but I don't know the y-intercept. But using y equals mx plus b and putting 1/5 in the place of m, I now need to find b. Well, I can use the ordered pair. The 10 would go in the place of x. The 1 would go in the place of y. So I would have 1 equals 1/5 times 10 plus b. 1 equals 2 plus b, reducing 1/5 times 10. Subtract 2 from both sides, b equals -1. So I've got the slope and the y-intercept. So y equals 1/5 x minus 1. F of x equals 1/5 x minus 1. Any question about that problem? Okay, let's see here. Let's take a look at another one of those. We've got an equation that has a slope of 1/4 and passes through the point 8, 1. So y equals mx plus b. 1/4 goes in the place of m. 8 goes in for x. 1 goes in for y. 1 equals 2 plus b. Subtract 2. -1 equals b. So y equals 1/4 x minus 1. F of x equals 1/4 x minus 1. Very much like the previous problem. Any questions about that example? Okay. Write an equation for a linear function whose graph has the given characteristics. It passes through 1, 7, and -2, 1. Okay, well, we don't have the slope and we don't have the y-intercept, except that we could use the slope formula. I'm going to call this first point, point 1, and the second point, point 2. So y sub 2 would be the y value of point 2, which is the 1, okay, right here. Y sub 1 would be the y value of point 1, which is the 7. X sub 2 would be the x value of point 2, which is -2. And x sub 1 would be the x value of point 1, which is 1. So then we've got what? 1 minus 7, which would be -6. -2 minus 1 would be -3. -6 divided by -3 is +2. So now we know the slope is 2, okay? So using y equals mx plus b, and the 2 goes right there. Okay, now we've got a situation like we did a little while ago. We know the slope. We don't know the y-intercept, but we've got ordered pairs. We've got 2 of them. Let's just use one of them. It doesn't matter which one we use as long as I use all of the same points. So x is going to be 1 and y is going to be 7. So 7 equals 2 times 1 plus b. 7 equals 2 plus b. Subtract 2. B equals 5. So the slope is 2. The y-intercept is 5. Y equals 2x plus 5. F of x equals 2x plus 5. Let's check our work. If x is 1, f of 1 would be 2 times 1 is 2 plus 5 is 7. So that checks. If x is 2, f of -2. 2 times -2 is -4 plus 5 is 1. So it checks. Any questions about that problem? All right. This says the graph passes through the point 30 and it's parallel to the graph of g of x equals -2/3 x minus 4. Okay, so again, we need the slope and the y-intercept. Parallel lines, let's see, what did we say about parallel lines? Parallel lines have the same slope. So the slope of g of x, the slope would be -2/3. So the line parallel to it would also have that same slope. So now we know the slope of the new line. Well, y equals mx plus b. Y equals -2/3 x plus b. We'll use the point that we've been given. X is 3, y is 0. 0 equals -2/3 times 3 plus b. 0 equals what? -2 plus 3 plus b, excuse me. Add 2 to both sides, 2 equals b. So I know the slope and the y-intercept of the new line. Y equals -2/3 x plus 2. Write it as a function. And there we have it. Are the lines parallel? Yeah, they have the same slope. And if x is 3, y is 0, so it checks. Any questions on that one? Okay, how about this one? The line passes through 54,0, and it's perpendicular to the graph of g of x equals 9x plus 5. Perpendicular. Well, let's see. What do we know about perpendicular lines have slopes that are negative reciprocals. What do we mean by negative reciprocals? All right. Well, the slope of g of x is 9. So the slope of the line that's perpendicular would be negative 1/9. So it's the reciprocal and then the negative or the opposite of it. So you flip it over and change the sign. So the new slope that we're looking for, and that symbol means perpendicular, is negative 1/9. So y equals mx plus b. Y equals negative 1/9 x plus b. Take the point for the new line, put the x value there and the y value there. 0 equals negative 1/9 times 54 plus b. 54 over 9 is 6. So b, 0 equals negative 6 plus b. Add 6 to both sides. 6 equals b. And again, we're using this slope, not the original slope. So y equals negative 1/9 x plus 6. F of x equals negative 1/9 x plus 6. And these two lines have slopes that are negative reciprocals, so they're perpendicular. And if x is 54, we get negative 6 plus 6 is 0, so the point checks. Okay, parallel lines, same slope, perpendicular lines, slopes that are negative reciprocals of one another. Okay. Next up, it says, write an equation that has the following characteristics. The line is horizontal. And it passes through the point -8, 12. Okay, so let's go back here again. Let's see. The equation y equals a number is a horizontal line. So this is a horizontal line, so it's got to be y equals a number. Well, what's the only y value that we know? 12. So it's y equals 12. Or as a function, f of x equals 12. That would be a horizontal line passing through the point -8, 12. You okay with that? Let's look at another one of those. This is horizontal. And it passes through 0.9, -32. So that would be y equals a number, y equals -32, f of x equals -32. Okay. Any questions about that? All right, we're going to look at a story problem. It says the following. Nurses. The demand for full-time registered nurses in the United States can be modeled by a linear function. So f of x equals mx plus b. In 2005, approximately 2,175,500 nurses were needed. By the year 2015, that number is expected to increase to about 2,586,500. So obviously this problem is old. since it's already gone past 2015. It says, let T be the number of years after 2000. Okay, so T equals number of years after the year 2000. This meant number long before it was hashtag. Okay. And N be the number of full-time nurses, registered nurses needed in the US. N equals number of full-time nurses needed. Okay. Write a linear function N of T to model the demand for the nurses. So it's actually going to be N of T equals MT plus B. Our input is T, our output is N. Now, T is the number of years after the year 2000. So in the year 2000, T would equal 0. In the year 2005, T would equal 5. In the year 2015, T would equal 15. You understand how that works? Okay, well, we'll find out if you don't. It says, so the demand for full-time registered nurses in the United States can be modeled by a linear function. In the 2005, approximately 2,175,500 nurses were needed. So that means we have the ordered pair 5, 2,175,500. So the year 2005 would be T equals 5 years after the year 2000. And then the number of nurses, 2,175,500. So that's an ordered pair I'm extracting from the story. Then it says by the year 2015, so then T would be 15, the number is expected to increase to about 2,586,500. Okay, so basically what I just did was I extracted 2 ordered pairs from the story. As we looked at earlier, several problems ago, if we have 2 ordered pairs that are on the line, we can get the equation. So first of all, let's get the slope. The slope is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, technically, the ordered pairs are t and n, but they're just like x and y. I'm going to call this point 1 and this point 2. Okay. Let's see here. Your microphone's on there. Okay. Antonia, your mic's on. There you go. Thank you. All right. So y sub 2 is 2,586,500. Y sub 1, 2,175,500. X sub 2 is 15. X sub 1 is 5. All right. So let's see here. 2,586,500 minus 2,175,500 is 411,000 divided by 15 minus 5, which is 10. That's going to give us what? 41,100. So the slope is 41,100. So y equals m x plus b. I put the 41,100 in the place of m. I'm going to use either ordered pair. And again, I know that these are actually t and n, but they're just like x and y for the formula. X and y, so we get 2,175,500 equals 41,100 times 5 plus b. 2,175,500 equals 41,100 times 5 is 205,500 plus b. We're going to subtract 205,500 from both sides, and we get, let's see, 2,175,500 minus 205,500. we get 1970000 equals B. Okay, so I know the slope, I know the y-intercept, or in this case, actually the what? N-intercept. So we'd say N of T equals 41,100 plus 1,970,000. So there is our function after we found the slope and the y-intercept. We put it in and then wrote it using T as our input and N as our output. Okay, that was part A. Part B says use your answer to part A to predict the number of full-time registered nurses that will be needed in 2025 if the trend continues. All right, the year 2025, T would be 25 because it's 25 years after the year 2000. So what they want us to find is N of 25, which would be 41,000. Oh, I left a T off of here, my bad. 41,100 times 25 plus 1,970,000. Okay, so the N of T would be 41,100 T plus that. Okay, so 41,100 times 25 plus 1,970,000, and I get 2,997,500. So that many registered nurses. If the author had ever known that we were going to have COVID and all the demand for healthcare and everything, so who knows how accurate this ultimately is. Any questions on this? So basically what we did was extracted two ordered pairs from the story. This whole idea about T is the number of years after 2000, that's a time shift thing, so that if you go to graph it, you don't have to use 2000, on your scale. You could just use the 5 and 15 and 25. Okay. All right. Well, that's all I have for you today. If you need to, go back and take a look at chapter 2.7, interval notation. Chapter 3 is where all these rules that I wrote down came from. Let's see here. This and that. Anyway, I'll be back at 1:15 if you have any questions. Otherwise, have a great day. Thanks for stopping by, and I will see you